So can we start, sir?
Yeah, okay.
Yes, Tejas.
You have to enable my video streaming.
Yes, sir.
Tejas, you can start. Switch on the video and start.
Good morning, all. We are the students of R&D Engineering College, Department of
The Institution of Engineers India, established in 1920 and incorporated by Royal Charter in 1935 and recognized as a scientific and industrial research organization by Ministry of Science and Technology, Government of India. And we are happy to present World Telecommunication and Information Society Day. The Institution of Engineers India Tirulur Local Center initiated in the year 2017 and executed the following tagged events titled as IEI Monthly Technical Lecture, IEI Statutory Day Celebration, IEI Battery, IEI International Seminars, IEI Tisla Awards, and IEI Intex. As on date, nearly 1,300 plus professional members, 22 plus student chapters, and 30 plus organized 120 plus events with 25,000 plus participants and 10,000 plus views in YouTube channel. In line with this, today we all gathered here for World Telecommunication and Information Society Day. Now I call upon Dr. L. Ramesh, Chairman, IEI Tirulur Local Center, to give his welcome address.
Thank you, Tejas. It was very great. Good evening to all the members, professional members who participated today in the Zoom and YouTube live, and also the student participants. As Tejas pointed out, Tiruvallur Local Center initiated in the year 2017, and we traveled in a good journey, which states that we are in 39th technical lecture, and we are celebrating all the statutory day, like Energy Conservation Day, Engineers Day, like that. IEA having 8 to 9 statutory day every year. So on that occasion only, today we are here to celebrate the Telecommunication Day. Not only this, we are giving appreciation for the IEA professional members, IEA student members through the IEA TISLA award. Not only that, IEA members, we have the student chapters, 27 student chapters, department student chapters, and 10 college-wise chapters are there, connecting all the academic institution, connecting all the industry and academy together. So this is what our objective. With that note, I am very happy to welcome our today's speaker, Engineer V. Pramod, Group Chief Technical Officer. Very warm welcome, sir. So you have good experience in telecommunication and going to give the address on 5G and edge computing. Very happy that very recently, 2-3 days back only, our Prime Minister launched 5G technology, which was developed by our IIT Chennai. It was very happy note, and I am very happy note that the video shoot which was initiated and presented to the IIT Chennai, my friend named Murugan, his team only did that. So with that note, I would like to welcome all the participants. Have a great another 40 to 45 minutes. We will have we will able to have the experience of the speakers. Thank you all. Thank you so much.
Thank you, sir, for sharing your wonderful welcome address. Now I call upon Dr. V. Cyril Raj, sir, Additional Registrar of a Dr. MGR Educational and Research Institute University and Committee Member of IEA Tirulur Local Chapter, to deliver his felicitation address.
First of all, I would like to thank our guest speaker, Mr. Pramod, as well as our friend also, as well as our former alumni also. So we are really delighted to see how you are elevated to this level, Pramod. We are proud of you. So this May 17th is a very important day. It is a World Telecommunication Day. The UN has earmarked that particular day to celebrate how the connectivity across the globe has made the entire globe as a small village. Right now, we have all our, at least one member of our family members are there in another part of the continent. So, but we never felt that actually they are away from us, both physically as well as emotionally also. Now, the only thing is the travel time. I mean, with the recent developments in traveling, no, even those things are also not such a difficult thing. So I could able to, even I have my own experience every day. I'm talking to my daughter who is away from me, I mean, with about 6,000 kilometers. So obviously, so we do not have any such a feeling also. So all these things are possible because of the developments which are happening there in the telecommunication. So thanks to Graham Bell, I mean, who have demonstrated how electromagnetic, I mean, the cables can be used to carry signals, and then how to convert voice, and then how to modulate, and then how to send it across over a carrier. So all these things have changed our life cycle, I mean, the way that actually we are enjoying the latest technology. Just, I mean, I can quote another example also. In 2015 floods in Chennai, all the mobile towers across Chennai was switched off. There was no, I mean, EB supply, or there was no generators of power supply. So totally it was, we were disconnected. And then at the time, we were feeling something like some strangeness, and then some fear, and then say has come into our mind. So that is the main reason is we are not able to talk to others, and then express our views, and then connectivity. I mean, all these. I mean, especially right now, if you cut down your telecommunication link, when the overall functioning of the entire system. I mean, in the sense, I'm talking about the functioning of everything that includes the economy, I mean, the production everywhere. So definitely, we cannot imagine about such a, I mean, situation at all. So, I mean, we have to pray God that actually, I mean, there should not be any such, I mean, future incidents, I mean, to the mankind without communication. So, right now, the communication industry is undergoing a lot of, I mean, developments. Right now, some of the countries have deployed 5G technologies, and then soon our country is also going to have the 5G technology with tremendous potential for high-speed data transfer across. And then at the same time, you know, IoT are coming up, and then with the IP version 6. I think you know that 128-bit addressing scheme will going to give enormous firepower to the communication industry. And then the expert is there who is going to give a talk on edge computing. How I mean, data sources can also be converted as I mean, the mean computing nodes also, so that clear all the decisions. Frontline processings can take place without latency. All these things, what I'm trying to say is soon there will be information explosion, and then through this information explosion, we are going to see yet more uh, user friendliness, as well as more facilities to all the service professionals also. So thanks to the IEI for providing such a wonderful platform for all of us to listen to the telecommunication day presentation by our beloved friend Mr. Pramod. Thank you, Pramod, for accepting our invite in a short notice. Thanks a lot.
Thank you, sir, for sharing your wonderful thoughts on World Telecommunication Day, sir. Now it's over to you, sir, Pramod, sir.
Okay. No, thank you, everyone, and Sir Saril Raj and Ramesh sir. Thank you for inviting me into this. It's a proud moment as part of being the alumni of Dr. MGR Engineering College to be presenting this back to the students, and I'm hoping other engineering students as well, who can actually get some value out of this presentation and can actually take this forward. So let me share my screen. Okay. So what I'm going to do is let me give a brief introduction about me and my company as well quickly before I head into what we want to discuss today about. So I am the group CTO for a company called as Inc. We are based out of Mauritius, and we actually invest in technology companies across sub-Saharan Africa. So this includes all the areas around Western Africa, Eastern Africa, and also the Southern Africa as well. So today we are actually present in 8 countries in Africa. And recently we actually finished an acquisition and now entering into South Africa as well, right? Now, as part of this process, what we do is basically we are an edge technology company. We actually have our own, patented technology around artificial intelligence. We are working, we have spectrum in various countries in which we can definitely leverage the private 5G, which is coming along. And we also service our clients specifically around edge cloud, and also in terms of providing software solutions to our clients as well, right? So from an Inc. perspective, what we do is we have 7 different products around edge and 5G. And this includes what is called as Fabric, where we can actually connect different edge locations. We do a whole bunch of things around artificial intelligence as a service platform, where we are able to actually do video analytics, document analytics, and even NLP based services, including IoT as well, where we are able to actually provide these services to our clients. The third element is around our universal CPE, which is more along how we actually take our solutions, which is out there, and convert that into more of a software solution, which we can actually deploy it in all of our clients' premises as well. Apart from that, we also do pretty much around bare metal as a service, where you can actually deploy edge locations anywhere in different countries, and then deploy it across various premises as well. In addition to that, of course, when doing all these things, one of the most important aspect is actually to do SASE-based services, which is actually to secure your edge locations as well, because that's extremely important, that not only you have to build edge solutions, but also be able to secure them. And that is one of the other solutions we do. And finally, obviously, once you have all these different edge locations, you need to actually monitor them And as part of this process, we also have our own solution around this for monitoring our edge nodes across the continent and across the world as well, using what is called as Elastic, whom we have partnered with. So with that in mind, I'm going to just quickly start around distributed edge and see why this is extremely important for us, right? Now, you might be thinking, we always talk about edge and what exactly is edge, because everyone thinks about moving to the cloud. And currently, most of the countries everywhere in the world, you will hear about, hey, why don't we use Google Cloud, AWS, or Microsoft Azure, and all of this. But what we are actually seeing is there is a huge progress, as applications evolve, that edge is actually gaining a lot of relevance. Now, if you look at from various premises, we have to understand why edge is very important right now, because when you are doing cloud computing, one of the most important part is that your data is actually going to the cloud. There is some processing happening and coming back, right? Now, obviously, that was very okay for non-latency sensitive applications. Like if you take, for example, your email or your, for example, the Zoom, it's fine, right? I mean, if the latency increases by a couple of 100 milliseconds, it's not really going to really impact the way you actually consume the application. But as more and more applications are coming in and more data is being generated, right, you need to have local processing capabilities as well, right? For example, let's assume that you're doing a driverless car, right? Now, when you're doing a driverless car and you're driving around and there's a processing which is happening, right? You cannot send all the streams of the data from the car into the cloud and then, get the response back, because by that time you would have probably hit someone, right? So you need to make sure that there is a local processing which is happening and you're able to manage this. And that's fundamentally why edge is extremely, extremely important. And as you can see, right, there is a lot of decentralization of the network which is happening. So if you see the way the applications are being built, they are no longer monolithic. They are actually distributed and they can reside anywhere, right? If you look at the way the next generation elements such as metaverse, which is coming in, or with the blockchain, right? All of this talks about decentralization, right? If you look at AR and VR, right, which is extremely important as well, is, you need edge for that to happen. Right? So for example, if you're, if you're wearing a VR headset and you're actually moving this along, and you're able to actually view the VR virtual reality headset, and you're actually seeing some things, and you move your head, right, that rendering of the graphics which is happening to give you that real-time experience, you cannot have a lot of latency, because if that happens, you move your head, but the rendering actually takes a lot of time for it to happen, right? So for all of this, edge is extremely important, and this expansion of edge is already being felt across the world. Even the hyperscalers such as AWS and GCP or Microsoft Azure are already launching edge devices which can actually communicate back into their cloud, right? And hence, as I said, 5G, IoT, AI, metaverse, blockchain, all of this, is driving the edge industry. So, and the most important aspect is the data residency and regulation as well, right? So in most of the other places, like for example, where, you don't have cloud providers, you may have to make sure that the data is actually stored on premise, because you cannot actually shift everything to the cloud as well. So in that sense as well, edge is obviously extremely important. So what exactly is distributed edge, right? So if you look at the entire system, what we have, the distributed edge talks about that rather than having one central place, which is called as the central DC or the public cloud, and then having one device, it is about actually distributing all of this into different premises, right? So what we call is we classify the edge into 4 different buckets. So we say what is called as what is happening on-prem and field. And this can be your mobile, right? Your mobile is actually an edge device, right? I mean, there's a lot of processing which is happening on your own mobile phone or your laptop, right? And this is on-prem, and yes, it's powerful, but it's obviously not as powerful as you want it to be, right? So that's where all the small kind of processing happens. So that, but you're extremely near. So if there is some kind of processing which needs to happen within extremely low millisecond latency, these are the devices which you want to place it on the premises, meaning it is actually in a specific place where it is actually being done. So this could be the processing power of a driverless car and all the stuff which happens, right? Now, obviously, once this processing happens, there is some small amount of data which needs to be further processed, which needs more compute power, which obviously your phone or your devices which is there on the edge cannot happen, because you need more compute power, meaning you need more power, you need more space, you need more capacity. So that what happens is you generally have a base station kind of a scenario where it is called as a deep edge, which means all these different on-premise and field equipment will actually connect to that deep edge system, wherein which the data being generated by these devices go into the deep edge system where the processing happens, and then the response is sent back. So in this case, obviously what happens is there is a slight increase in the latency, but obviously what you're now doing is you're now able to manage all of this in a better way, right? Rather than sending it all to the cloud, which takes a lot of latency, you're now able to do this. So if you actually go to AWS Wavelength, right? AWS launched a service for Wavelength, which is actually exactly this system. So what they do is that Wavelength system can be installed in base stations across any places. So if you have a telecommunication base station, you can actually install this Wavelength device there. And what happens is that on that, you can actually deploy edge applications, which can be used for AR, VR, driverless car, and all these different applications can be done that. So you can actually go and read about Wavelength and Verizon, how they are working together in the US to solve these issues, right? Now, obviously, once this part is done, there could be an extremely even more high computing resources which is required, and for which you then have a central office or an aggregation point. So basically what then happens is multiple base stations of different, from different areas will communicate and will connect to this in a central locations, and then we'll be able to run through this process, right? So that is fundamentally the next step in terms of going through this, going through this process. Now, once all of this is done, then the next hop is basically to go into the regional data center and then run through the process of, where the actual processing happens, where the data storage actually resides. So all of these things happens on the regional DC or your public cloud. Obviously, this is a place where there's a lot of storage and there's a lot of backup. This is where you actually store your data and everything else, so that even though something happens to your edge device and you bring another edge device, you will be able to get back all your data, right? So that's how you distribute these systems. Now, when you look at this architecture, you might ask, okay, this is all fine, but how is it relevant, for example, to 5G, which is coming along? Now, the way 5G has been built is basically to incorporate these elements together to make sure that we are able to actually leverage these same set of technologies and be able to, put 5G as an application which can be deployed in this similar fashion. So what you can think of this is, while edge is the architecture, 5G is the application which can actually sit on top of the edge. So if you look at how a 5G architecture looks like, you can actually see here that there is a cell sites, right? And then from the cell sites, it comes to a radio unit, and multiple radio units connect to multiple distributed unit, which is the base station, and multiple distributed units then connect to a central unit, and then that central unit then connects back to the cloud. Now, if you look at the way this is structured, right? And if you go back and see how distributed edge is, you can see that similarity that both of these are actually in the same place, right? So you can see the cell sites are basically your on-premise, your radio units are the first, edge locations, and the distributed units are the aggregated locations, and the central unit is where the, you have the edge aggregation point, and then where the cloud is where your packet core or your core infrastructure actually sits. So that's fundamentally how the connection is basically being made, right? So when we look at edge overview, right, we need to understand what are the elements which we need to go towards when building this edge infrastructure, right? Because this is fundamentally one of the most important aspect which we need to look at, because what you can see here is, when you are developing an edge architecture, what do you have to keep in mind, right? The first thing obviously is the infrastructure, right? Because remember, in a cloud infrastructure, you have access to a lot of power, you have a lot of security, you have everything. But the moment you now start talking about edge, these are all places where you don't have enough power. They have to stay in a place where there's not much of connectivity. So when you look at all of these things, then you have to keep to think in mind, how do you manage these things? So in that sense, you have to look at the power of these edge devices. You have to look at the capabilities of these devices, because even though they are very, very small, what kind of processing can be done on that? So today, for example, this is extremely important, is that your normal small, you get these Arduino boards, you get these Jetsons from NVIDIA, all these ones which are basically small edge devices, have extremely high powerful capacity, because they can actually process a whole bunch of really, really good applications, right? And most of them today is actually either x86 technology or ARM. But today ARM is actually winning this battle, because obviously ARM architecture is in such a way that it has been built for the edge. That's the reason why, if you see, almost all your mobile phones are built on ARM, right? Because it takes very less power, it doesn't get heated up, and it's able to actually perform better processing compared to x86 on a per core per power unit level, right? From an orchestration perspective, one of the most important thing we have to consider is, once you have all these infrastructure, you need to now look at, how do I orchestrate this? Because remember, in a cloud, you are actually looking at, you go to AWS, you spin up an application, and that's it. With a couple of clicks of a button, you're able to spin up a virtual machine, you can install an application, and you're done. But when in edge point of view, you now have to look at not just bringing up a virtual machine, but also how do you manage that infrastructure? Because now you're looking at not 10, but rather hundreds and hundreds of devices, right, which you have to orchestrate. So now it could lead from 100 to 1,000. Then how do you make sure that you're able to manage that large footprint of devices? How do you do zero touch provisioning? Meaning, when you switch on the, let's say, when you switch on the box, how do you make sure that you're not actually, also, shipping an engineer on site? Because then it will become very expensive, right? So the way it should work is, you should be able to ship an edge box, and they switch it on and it should start working. So that is zero touch provisioning, right? So that's how do you make sure that works. And not only just that, how do you manage the overlay of the network, right? For example, there is compute, there's storage, there's network. So how do you manage all of this on an edge box? So that is why edge orchestration is extremely important, and a lot of companies are giving thought about, how do we orchestrate that on the edge? Because now you're looking at scale, which you have to do that. Now, when you look at both of these things, you might think, yeah, this is all there is to edge. But the most important aspect is the security point of view, right? Because remember that, whatever you talk about this today, cybersecurity is one of the most important element from an edge perspective, as well as from a cloud perspective. In the edge, it is lit even more prominent, because if you look at from a security point of view in a cloud, right, you have a lot of layers of security. For example, if you let's just spin up a virtual machine in Amazon, for you can be assured that there is no one who will be able to come into Amazon's data center, get into your server where your virtual machine is, and hack into that, right? It's almost extremely remote, because there's a lot of layers of security, there's a lot of protection, and most of the times people don't even know where these data centers lie. I mean, they go to that level of security there. But now when you're talking about the edge, right, these devices are sitting probably in a storeroom, right? Or it could be sitting in in the small box which you see in somewhere where all the switches or everything lie there. So that means it's much more easily accessible to everyone. So if somebody wants to actually attack you, all they have to do is get into one of the edge device and you're done, right? So obviously what happens is, now that you're shipping all these devices, your attack footprint actually increases. And obviously once you compromise one device, the rest of the system can be compromised fully, right? So that's the reason real-time monitoring and prevention of attacks is extremely important, and security is one of the more core principles of edge, because without which it cannot sustain. Now, once you look at this, the next step is obviously, yes, you have done all this, but you have to make use of the edge, right? What are the applications which you can deploy on the edge, right? So one of the most important thing is IoT. So today, most of the edge applications today you see are based on IoT, right? Because obviously IoT requirement is such a way that you need that system to be extremely close, so that when the sensors detect something and the processing happens, it should be able to respond back immediately and control an actuator, right? So for that, that's the reason why you see there is a lot of push towards IoT and IoT and the edge, right? The next one is obviously artificial intelligence and deep learning, right? Because what you are suddenly seeing is there's a huge growth in artificial intelligence capabilities, right? If you look at for example, object detection, if you look at, for example, NLP, all of these things work on set of data which are extremely large. For example, if you look at object detection and say, look, I want to detect if there is a car coming in and if that person is holding a cell phone, all those elements, then obviously what you need to make sure is that the streams of video from your CCTV is not being sent to the cloud, because obviously that will be latent. First of all, it's extremely bandwidth heavy. And then when you send it to the cloud, it takes really long time for it to get processed. So how are you able to make sure that you are able to actually deploy your applications on the edge, wherein which the stream of, the CCTV stream is recognized, analyzed on that device, which is local, and then it's able to understand and say, oh, look, this is happening here, and only send the required report back into the cloud for storage, but not the entire data, right? So that's why there's a lot of elements around AI and deep learning which is being put on the edge. Of course, when you talk about AR, VR, as I was mentioning, is extremely important, because obviously, you need to make sure that the latency is too low, and almost all AR, VR, applications are built on the edge, right? And as I mentioned, 5G is one of the other element which is obviously taking edge by the stride. And 5G is now, previously you had physical boxes, where you had to deploy. Now all these solutions are actually coming as virtual environments, or you can even run as Docker containers actually, right? So for example, you can go and read about how Rakuten in Japan has rolled out, their 5G network, right? And all that 5G network is actually built on containers. They're not even using virtual machines, right? So you're going into that level of, sophistication of your actually mobile network operators are actually going towards. So hence 5G also becomes, one of the applications on the edge. So now when you look at from an architecture point of view, right, what are the components which, if we go a little bit deeper, right? So the first thing, obviously, for anything to happen is Linux, right? Because if you see, without Linux, the world stops, right? So obviously, you need to have a low latency Linux. That's your operating system, which sits on your edge infrastructure. And on top of it, you need to have certain key elements which can actually manage your baseline infrastructure. For example, you can have your PostgreSQL, Calico, Docker, all these are baseline applications which help you in orchestrating this entire elements, right? And these are the fundamentals on which your entire edge actually sits on top of it. Now, obviously, once you have all of these, you need a configuration management, a service management, a fault management, host management, infrastructure orchestration, which can effectively manage all these different small components to give you storage, network, compute for your applications, right? And once you're able to do that, you obviously need a fully blown orchestration system, which can actually help you in deploying these applications on top of it. So Kubernetes, if you look at it, is one of the most important applications, because today most of your applications are anyway containerized, and Kubernetes can able to orchestrate those things on top of your edge devices, right? And it is meant to be distributed. So Kubernetes by default was constructed to have it distribute in a distributed environment, right? So apart from that, you also have, for example, the distributed edge cloud, which can be built on OpenStack as well. So OpenStack and Kubernetes, if you see, are the fundamentals on which most of your edge orchestration is built on. So now when we look at that, we need to understand what are the tech stack for our applications, right? So if you look at from an application point of view, we look at from a packaging perspective, because we are able to have a different packages, and then we move into networking, because that is fundamentally where you have different applications such as zero tier, which can help you for doing encrypted packets. And then you need sensors, obviously, for managing all these different elements. And then one of the most important thing is basically when we go into the next level of details is obviously your operating systems. And today, as I mentioned, the operating system is obviously around Ubuntu or Arch Linux or CentOS, which can help you to do this. And then as you go into the next level is basically your orchestration levels, which is Kubernetes, Docker Swarm, or OpenFast. And then on top of it, you actually have your applications, which is around PyTorch, NVIDIA, Redis, Kafka, and all these elements are actually open source. So effectively what it means is to build your edge stack, tech stack, you can actually leverage open source as much as possible so that you are not actually paying someone a huge amounts of money to do this. The other elements, one of the important element is basically system on chip, right? So while edge is extremely important, I think this is what a very, very important to make sure that, we are able to actually push it through this direction. And when you look at the way in which edge is working, I think fundamentally, miniaturization is the way to go, right? I mean, previously, if you see, there was a desktop where you had all these systems put together. And then now, that's the reason why your desktops were too big, right? But now I think, if you see how it's coming up, all the different elements, if you take your desktop, right, and if you see the motherboard, there is a GPU, there is a network, there's a RAM interface, all of those things are now miniaturized into one central umbrella, which is called system on chip. So that effectively means you're actually bringing down your motherboard into a small element, which is like a chip on which everything else is built in. So that way you don't need multiple different applications to be there, right? So that makes this process extremely easy, and also, from a power point of view, it makes it very, very good. So as we look at from an applications to the edge perspective, we start from a mobile, because that's something which is already there. Now we are looking at IoT and AI ML, but obviously in the next generation world, we'll be looking more from a network function virtualization to virtualize your existing routers and switches on top of a virtualized environment. And then, as I mentioned, we'll also be looking into 5G as well, where we are looking at driverless cars, AR, VR, and obviously even 5G infrastructure as well becomes one of your core applications on top of it. The other elements is one of the most important aspect, as I said, is the cybersecurity attack on the edge. As you can see, there's a whole bunch of elements which we can look at, right? So there is malware, wherein which people can route your edge devices. You can have man-in-the-middle attacks, and then you can actually have spoofing environments or impersonation, where somebody can actually bring a rogue edge device and they can actually take over the entire network. And then you have DDoS attacks, where they can actually hit you and bring down your entire infrastructure completely. So these are some of the elements. So while keeping in mind, so what are the different elements we need to look at, right, from preventing attacks on the edge? So obviously the first aspect is obviously to encrypt everything. So when you're transmitting a data from one point to the other point, we need to make sure that we are able to, encrypt as much as possible, right? And the second thing is using secure tunnels. So obviously, even though you are encrypting all the data, you need to set up all your tunnels are also secure. So that adds as another different layer of encryption. And then when you're deploying, in the edge, one of the most important things is there's always going to be issues with the code, right? With an application, right? So if you remember, there was attacks on Log4j a couple of months back, and if you don't have a good way to patch your applications very quickly, you will be prone to the edge, right? And obviously, since edge itself is decentralized, it's important that you need to have a proactive monitoring, so that even though you see there is a compromise which is happening on the edge device, you will be able to remove that, analyze that very quickly, that this edge device is compromised, and you can remove it from the network. So that is very, very fundamental for going through this process. So I think with that in mind, I hope you enjoyed the session on edge computing and distributed edge computing and why it is important. I'll kind of hand it over to the team and let me know if there are any questions. And if not, you can reach out to me on pramodv@inc.inc. That's my email address. I'll put it on the chat as well, so that if you have any questions or anything else, you can definitely reach out to me. And once again, I thank the MGR University team for inviting me, for giving this opportunity to present to you guys all. Thank you.
Participants, if you have any questions, please ask with sir. Or you can make your questions in chat box so that we can ask to sir.
Oh.
Team, I would really thank you, because unfortunately I have another call which I have to jump on to. So if you have any questions, you can email to me on my email and I'll be happy to respond to that.
Yes, sir. Thank you so much for your coming, sir. So this is Dr. J. Balamurugan, Secretary of IEI TVLC. So in your busy schedule, so you extended your home and quite useful information which you have shared in this platform. So we'll stay connected, sir. So as you have your pre-commitment, so thank you so much for your presence, and your title was excellent title, and the content was also so precise, and it was so happy that we would have a more enlightenment at the later session. We'll catch you. Thank you so much.
Thank you so much.
Thank you. And Teja?
Yes, sir.
Please collect the questions from the participants so that we can mail it across to sir, and so that we'll stay connected. And you can also share the mail ID to all the participants so that the people can directly connect with the sir and so it's possible directly.
Yes, sir.
Okay, so ensure that all the people are satisfied with it, and you can also post a survey questionnaire for any enhancements. People, if you have any suggestions, please post it in the suggestions box so that we can enhance thereafter, and we have more delightment as well as insight of all such technologies to be displayed for you. So like whatever requests you have also, we can arrange for a meeting to Institution of Engineers. So right now, Institution of Engineers have more than 1,300 people enrolled or located. We have more than 25 centers across, there is 125 centers across India, but we just include our local center. We have more than 40 colleges and more than 100 industries connected, but still we are lagging behind what is MIG and SIE means. We are there in your doorstep to help you. So that if you want to become a member, please log on to ieindia.org. So it's a simple process that you can become a member. So if you can fill in the form and make the payment, automatically it would be dispatched to your home. So that is as simple as it is. Ensure that you are staying connected with the technologies through IEI through your local center. Thank you so much, participants. Thank you, activity manager, for arranging a wonderful lecture today. So through this telecommunication day, so Sirij sir was rightly pointing out telecommunication is very much important in connecting all such people. It's a good opportunity for all such participants to connect because of this telecommunication network, wherever you are, still we are connected with the technology. So there is a happy ending for the day. So thank you so much.